Okay, this lecture is over Chapter 3 of your textbook, which is entitled Decision Structures and Boolean Logic. So here's a list of the topics that we will be covering when we go through this. We'll talk about the if statement, and then there's different variations or different uses of the if statement. So we'll talk about the simplest use, and then we'll talk about if-else statements, and then we'll talk about if, else if, else statements. In the process of doing this, some of the operations and comparisons we need to deal with was we'll talk about how to compare strings. We'll talk about logical operators. Related to logical operators, we will talk about Boolean variables, which are variables that can have true-false values. We'll talk about conditional expressions. We'll talk about assignment expressions again, and a form of the assignment operator that's referred to as the walrus operator. And then we'll look a little bit more at turtle graphics, including determining or querying the current state of the turtle. So the first thing we want to do is talk about control structures. And what a control structure is in a programming language is a logical design or structure that controls the order of executions of statements. So up to this point, I believe we've talked about what I would call a straight line program, which they here call a sequence structure, which is just statements are executed in the order they appear. So when I say straight line program, I basically mean start at the top, go down the program executing every line, and then you hit the bottom of the program and execution ends. In the case of decision structures, it's going to allow us to change the flow of control or take alternate paths of execution, if you will. So decision structure, sometimes called selection structure, and the if statement that we're getting ready to talk about is the first decision structure that we will talk about in this class. Hopefully you're familiar with this from your CIT 120 class, which is a prerequisite for this class. So the textbook talks about flowcharts. Basically what happens is if we're going to make a decision, the symbol we use is a diamond. And within that diamond, we tell what condition we're testing. And then depending upon whether that condition is true or false, we take alternate paths of execution. In the simplest form, we have if condition block of code. So if the condition is true, we would execute that block of code. If we came down and hit that if statement and the condition was false, we would jump over that block of code, continuing on with the first Python statement that was after the block of code associated with the if statement. So in a flowchart, here is what we're doing. We want to know if it's cold outside. If that's true statement, then we want to wear a coat. If that's false, then we skip that wear a coat section of the code and just continue on with our program. So this is pretty much the simplest form or simplest case of an if statement in any programming language. So the syntax for this is we have the keyword if, that is followed by a condition we want to test, and then a colon at the end of that line, and then indented consistently under the if is a number of statements that you want to execute. If the condition is true, those statements are executed. If it's false, we jump over or skip that block of code. Now, when we're talking about test conditions, we talk about Boolean expressions and or relational operators, because these are things that appear within the condition. A Boolean expression is an expression that can be evaluated to either true or false. So the example they give here is the value in A greater than B? If A is greater than B, then that's going to return a true. If that is not the case, that is B is greater than A or equal to A, then that Boolean expression is going to return false. So when we're talking about values, that Boolean expression uses what's referred to as a relational operator. In this case, the greater than condition or greater than symbol. There are lots of different symbols we can use. We just saw greater than. You have less than. You can have greater than and equal or less than or equal operators that test for those conditions. The next one is usually referred to as the equality operator. Back in chapter 1 or chapter 2, I don't remember which, we were talking about the assignment statement, which is variable equals expression. And I told you that often when you have an equal like that, instead of saying equals, you say gets set to. So x equals 10, you might read as x gets set to 10. And the reason I said that is because of what we have here. When you have two equal signs together, you're basically asking the question, is the variable or expression on the left-hand side of that double equal exactly the same as whatever expression appears on the right-hand side of the double equal. So that's why they say do not confuse this with the assignment operator, and why I told you you might read a single equal as get set to. That checks for equality. If you want to check for inequality, which is not equal to, it's an exclamation point immediately followed by the equal sign. Here's some examples of these. I think we talked about all those on the previous slide, but this is examples and in English what they're checking for. So instead of just saying is it cold outside, we're giving a little more detailed example here. Basically, we have a value for sales. It looks like that may be a person's sale for amount for the month. So basically, they're saying if sales is greater than $50,000, then their bonus is $500. So if they, you might refer to that as their quota. If they exceed their quota, they get a $500 bonus. If they don't exceed their quota, then you skip that bonus section and they do not get a bonus. So there's a little more detailed example using flowchart. Here they're talking about just testing and making decisions based upon conditions. So nothing really new at this point. If balance is equal to 0, if your payment is not equal to your balance, then you need to do something a little different. Now then, what they're talking about now is putting an if statement inside another if statement, and you just have to follow the indentations. So they're just telling you that can happen. this is kind of a special case. If you only are going to execute one line of code, you can actually put that line of code on the same line as your condition. There's debates over whether that's a good thing to do or whether you should indent it based on what the likelihood is that you might come back, and if that condition is true, might want to alter the code. Because if you use this single line statement, then when you go back to change it, you're going to have to remember to pull that down and then indent the other block of code. And Python uses that indentation so that you're less likely to make mistakes. But it is possible that you would put lines of code in here that you intended to be part of the block of code executed if the if condition was true. And really what would happen is, in the case that the condition was not true, you wouldn't execute the line of code that was on the if line, but you might inadvertently execute all the other lines of code that you intended to be within the block. They're calling this a dual alternative decision. So if you want to test a condition, and if it's true, you want to do one thing. If it's false, you want to do another. So if condition, block of code, else, block of code. Now, what I was thinking about when I saw the flowchart 3 slides ago is really that's not the best thing to do. Either before that condition you needed to set the bonus to 0, or you needed to use a construct like this that says if sales is greater than 50,000, then the statement for the true block would be bonus equals 500, else bonus equals 0. Because if you got down later and said their pay is their salary or their sales plus their bonus, in the case that they didn't meet their quota, bonus was going to be undefined, and you would get a runtime error when you did that. So again, the else needs to be indented, even with the if, and then all of your statements need to be indented consistently as well for the Python interpreter to be happy with this code. So here is the flowchart showing, going back to is it cold or not. Now they're actually defining what cold is, and the person designing this decided or was told that cold is a temperature less than 40 degrees. So you're executing along, and then it says if the temperature is less than 40, print out it's a little cold, isn't it? If it's 40 or above, then nice weather we're having would be printed. So this is that dual decision alternative path based on an if-else statement. So here they're just going through and talking about what happens on the left column. Basically, if the condition is true, we're going to execute all the statements in the condition block, and then the flow of control is going to jump down right after the if statement. On the right hand side of this slide, if we test the condition and it's false, then we're going to execute the block of code that is associated with the else statement, and then continue on the next line of code that is outside the if-else statement. They kind of go off on a tangent here, talking about comparing strings, comparing numbers. We've been doing that since second grade or whenever we learned about number lines. and knew that one number was less than a number if it was to the left on the number line, or greater than if it was to the right. But testing strings might not be as obvious. Again, because Python was kind of born out of a Unix world, things are case sensitive unless you tell them they are not. You can compare strings using greater than, less than, greater than and equal, or less than equal. And basically, the ASCII character set was designed in such a way that if we do these types of comparisons, and what they'll detail here in a moment, basically something is less than another string if it would become before it in a dictionary. If there's a word that has 3 characters, and then there's another word that has the exact same 3 characters and additional characters, then the shorter word is going to be less than the longer word. So here they're showing you whether Mary and Mark, which would be less than or greater than. And I said dictionary order, which you should hopefully look at and say, well, they're both 4 characters in length. Mark would come before Mary if we were doing this in alphabetical order. Here they're showing you the character values, though. Capital M is 77. Lowercase a is 97. Lowercase r is 114, so we're exactly the same up to that point. But when we get to the last character, K is 107 and Y is 121. So numerically, 127 is less than 121, which would make the letter K less than Y. So we would do that comparison, and Mark is less than Mary. Here they give an example of where you might want to nest an if statement. You want to determine if somebody qualifies for a loan, and there are 2 conditions. They must make more than $30,000 a year, and their employment must be at least 2 years in length. So you check the first condition, and if that's true, then you check the second condition to see if they can get the loan. If the first condition is false, then they don't get the loan, and you can skip over doing the second test or condition. So in a flow chart, here's what we have. Is their salary greater than or equal to $30,000? If that's false, you tell them they don't qualify for the loan, and you tell them why, because they must make at least $30,000. If their salary is greater than $30,000, then you continue on, and you ask if the years on the job is greater than 2. If that's true, then you tell them they qualify for the loan. If that's false, you tell them they don't qualify for the loan, and you give them the reason that the years on the job needs to be greater than or equal to 2. Again, the indentation, that is how the Python interpreter figures out what is in blocks of code, what's within a condition. And they force you to do that because it needs to be readable for the programmer. I used to teach Perl for years, and I would tell my students, I didn't care exactly how many characters they indented, but they needed to indent it so that their code was readable. So even though Perl, you could shove everything in column 1, and it would work correctly, that is not good programming style. So basically, Python is forcing good style on you, while at the same time using that to check the syntax of your Python statements. Another thing that's real handy is you could write a flowchart that kept having decision blocks and decision blocks within decision blocks within decision blocks, and each of those diamond decisions would be an if-else. But when you have a construct like that where you're basically looking for one condition out of a set of conditions to be true, you would use what's referred to as the if-else if. Now, some programming languages spell it else if, E-L-S-E-I-F. Other programming languages name it E-L-S-I-F. In the case of Python, it is E-L-I-F. So even though that's kind of abbreviated down, I would probably still read this as if condition, else if condition, else if condition, and then down at the bottom you would have a single else. So what happens is from the top down, it would find the first condition that was true, and it would execute the block of code associated with that condition. If none of those conditions was true, regardless of how many there were, then the block of code in the else clause of the if statement would be executed. Again, you need to have proper indentation. Sometimes you, like I said, there are other ways to accomplish this, either just because you do it that way, or some programming languages only have if-else statements. So you can use either, but a lot of times using else if, even when it's not required, would make your code easier to read. So here is one of those things where you have a number of conditions you want to check. So, you're basically implementing a traditional grading scale. 90 and up is an A. If you have made less than a 90 but greater than 80, then you're going to print your grade as a B, etc. Okay. The Boolean and relational expressions we've seen so far are fairly simple in nature, but sometimes you will need to make more complex Boolean instructions. For example, I don't know if they're going to use this or not, but in the loan, you could do that with one condition that says if salary is greater than 30,000 and years on the job is greater than or equal to 2, print out congratulations, you get the loan. So instead of doing two checks, using a compound Boolean expression, we are able to kind of simplify our code and check multiple things within a condition. There are a number of logical operators. I will probably do an alternate or a supplemental lecture on logical operators and truth tables associated with those logical operators. But right now, the ones we want to talk about are and, or, and not. So those are kind of the three most common Boolean operators. There are some others. I believe your book talks about exclusive or, but we'll see here in a moment. So basically, a Boolean operator, it says it takes two Boolean expressions. It's not exactly true. Most operators, logical operators, are Boolean in nature. And you can even say, but there are some unary operators as well. So a binary operator means it takes two arguments. So you have one argument, the operator, and then another argument. For a unary expression, for example, not would only take one argument, and it would complement or take the negative of or the not of whatever expression followed the not operator. So here we have the truth table for and. So the expression is true. The expression A and B is true if both A and B are true. So I would actually name the variables, and I will do that in my supplemental presentation. But then we write the combinations kind of in binary, because a lot of languages represent false as 0 and true as 1. So if you look at their statements, it would be 0 and 0, 0 and 1, 1 and 0, 1 and 1. Or using the Boolean value, it would be that. So the expression A and B is only true if A and B are true. So the only time that is true in this truth table is the very last line, which is true and true results in true. All the other combinations result in false. So that's what a truth table is. It shows you the results of Boolean operators. We can use or. So down here at the bottom, A or B is true if A or B is true. So we have at least one true value for all the lines except false or false. And they made a mistake here. Obviously that operator should be or in their truth table, not and. A lot of programming languages, or at least some programming languages, I know this was a big deal with Perl, and Python has this concept too, which is short circuit evaluations. Basically what happens if you have condition and condition and condition and condition and condition, and let's say you have 50 conditions you're checking. Once you hit a false, no matter what occurs after that, there's no way that the expression is going to be true. So and is a short circuit operator, and basically the way it works is the first time you encounter a false, it is going to stop evaluating the conditions and simply return a false value, because again there's nothing you can do to make it true. Likewise with the or operator, which is also a short circuit operator, if you have condition or condition or condition or condition and you have 50 of those, as soon as you hit a condition that's true, there's nothing that you can do to cause that to change to false. So in the case of or, the first occurrence of false stops evaluation of the conditions and returns false. So that's what short circuit evaluation is, and again it applies to the and operator and the or operator. The not operator, sometimes called the complement, is kind of like you would read it. Not false is true, not true is false. So it complements or takes the other value of the variable as the result. This is just showing you a couple of conditions where you would use these with numeric comparisons. If x is greater than or equal to 10 and less than and equal to 20. So another way to say that is if it's between 10 and 20 inclusive, then this is going to evaluate to true. Otherwise it would evaluate to false. Down here we're looking to see if a value is outside a range. So if x is less than 10 or x is greater than 20, for some reason we want to check that. If we get a value between 10 and 20 inclusive, this would return false. But if it was outside that range, then it's going to return true. As I've kind of alluded to, and they've shown, you can have values whose type is Boolean, or shortened to bool, B-O-O-L. These are variables that are capable of holding a true or false value. And what they're telling you is a lot of times you use a flag, like you might set a variable to done is false, and then you might execute a loop or do things until that flag turns true because some condition was met. So a lot of times you can use those as a Boolean expression or value to determine whether or not a loop terminates, for example. A conditional expression is of the format value 1 is the result if condition else value 2. So you could write this as an if-else statement if you wanted to, but this is kind of a shorter version. Notice that the if and else both appear, but again it's value 1 if condition is true, else value 2. So that's just kind of a simplified or shorter version of a common situation or a common thing that you would want to do while programming. So here, we want to set their grade to pass if they made above a 59. Otherwise, we want to set it to fail. And again, they're showing you that yes, we could have done this with an if-else's statement, but this is definitely shorter. People are going to have different opinions on whether it is more readable or not, but that's up to the individual to decide and determine which construct they would want to use if they were programming. Here we're saying the max is equal to num1 if num1 is greater than num2, else num2. So basically what we're doing is we're putting the larger value of two values into the variable max. And again, they're showing you the equivalent way that you could have accomplished this if this conditional expression was not available to you. Now, the walrus operator. I kind of understand because I've done Perl where this comes from. They decided to make it very clear. Basically what happens in Perl, every expression you execute returns itself as a result. And you can use it in conditions or that type of thing. However, in Perl, if you're just executing along and you set x equal to 5, it's going to set x equal to 5 and then just kind of return 5, and you don't have anywhere to put it. So Perl's just going to ignore that. Well, what happens in Python is a little bit different. The walrus, first of all, you have to say, I want this type of behavior by using the equal and the equal sign. So basically, this is like old emojis. If you tilt your head to the left, that operator kind of looks like a walrus, his eyes and his teeth sticking down. What the walrus operator does is it does an assignment, but then whatever value is assigned to the variable is returned in place of the expression. Now then, here's an example. So in this case, num is going to get set to 99, and then a 99 is going to be returned in its place, so that print statement becomes print 99, and that is going to be printed out as a result of the print function. Here we're doing a calculation, which is width times height, assigning it to the variable area, and then we return whatever that value is in place of that whole expression, and then we ask, is that greater than 100? And based upon whether that's true or false, we, if true, print the error message. If false, we do not. So that's kind of what I mean by returning in place of the value. We're going to talk a little bit more. I will probably have a supplemental lecture on precedence and associativity of Python operators. But the Walrus operator has the lowest precedence of all operators in Python, which means it is going to be the very last thing that happens if you have an expression that uses different operators and ands and ors and that type of thing. You know, if you want it to happen in some different order, just like all precedence of operators, you can put parentheses around it to kind of force it to happen when you want to happen if it's not the desired effect. So here they're telling you, for example, this num equals 99 at the top. In Perl would be happy with that and just return 99 and say that doesn't make any sense. Well, the case in Python, there's a couple ways to look at it. A lot of times in Unix, when you return a 0, that's successful. If you return a value, it's unsuccessful. But in Python, this is just considered syntactically incorrect. You know, if you use the Walrus operator, you have to have a place for that value to go. Like we have down here, it would go as an argument to the print function. Okay, as seems to be the case, at least in 2 of the 3 chapters we talked about so far, is they incorporate some information about turtle graphics, and what we are talking about is determining the state of the turtle. Here, this example is using a couple of functions that I believe we talked about in chapter 2, y coordinate and x coordinate, and they're building that query or status or state of the turtle into a conditional expression. So they're saying if the y coordinate is less than 0, then I want to go to you know, the center of the screen, coordinates 0, 0. You can do a complex thing. Basically, if the x coordinate is greater than 100 or the x coordinate is less than 200, I want to position to coordinate 0, 0. So we're querying the status of the turtle as well as using that information in a conditional statement, in this case, the if statement. Here we can query the heading, which is which way the turtle is pointing. We talked about that before. So if we are somewhere between 90 and 270 degree orientation, we want to change the heading to 180. On this one, we're going to toggle the status of the pen. That is, if the pen is down, then we want to bring it up. If the pen is not down, which means it's up, we want to take it down. So basically, like I said, we are toggling that. You could actually combine that into an if-else, because if the pen is down, then you know it's not up. And you could have those statements again in a single if statement. If the turtle is visible, we want to hide it. In this example, we want to change the pen color possibly. Pen color is going to return a string. If that string is red, then we want to change it to blue. Down at the bottom, if we get the fill color, and if it is equal to blue, then we want to change the fill color to white. So again, decisions made upon results of querying information about the turtle. In this case, if the background color is equal to white, notice the use of the double equal, then we want to change it to gray. The other thing they pointed out last slide or slide before is a lot of these functions, if you call them with no arguments, give you the current status. If you call it with an argument, it sets it. So BG color with no arguments is going to turn the background color. And like I said, if it's white, then we want to set it to gray. So then we have the argument gray going to turtle.bg color. Here, if we have a small pen size, which is less than 3, we would like to set the pen size to 3. Here, if we have a speed that is greater than 0, which means we do have some speed, then we want to set it to 0, which means things appear immediately. There is kind of a little game in your textbook called Hit the Target, and basically what you try to do is you try to go through and see if, based upon where you're positioned, can you draw an arrow that's going to fall within the square that is on the screen. So you can play around with that, getting information from within your textbook. So that finishes up the Chapter 3 lecture. Here's a summary of all the things that we talked about and that you should be learning within this chapter.